This video should help you with the first section of your summer assignment, significant figures and scientific notation. Just as a review, sig figs are all of the certain digits that you'll see in a measurement, as well as the one uncertain digit. And then any non-zero digit, anything running from 1 through 9, will always count as a significant figure. Leading zeros, the ones that come before your first non-zero digit, will never count. Captive zeros, the ones that fall between non-zero digits, always count. And trailing zeros get to count if there's a decimal somewhere in the number. So for example, 30.0 amperes would have 3 sig figs, while 30 moles would just have 1. When you're doing calculations with significant figures, adding and subtracting, you look at decimal places. You want to go with the measurement that has the fewest to determine how many you should have in your answer. While when you're multiplying and dividing, you want to look at sig figs. The measurement with the fewest sig figs is the one that you want to report in your answer. I'm going to show you one example of a calculation that involves addition, subtraction, as well as multiplication, division. In that scenario, you follow your order of operations, and you do have to use both rules. So here are 3 examples involving significant figures. If you can put the numbers in scientific notation in your calculator using the E button above number 7, or you can go ahead and do the times 10 with the caret, but remember you have to watch out for your parentheses when you do that. You can also simplify the numbers before you do the exponent math here. But this number has 3 sig figs, it's still a multiplication. This one also has 2 sig figs, so you want to report 2 in your answer. And so that would be 0.0034. I would also take 0.0034, or 3.4 times 10 to the negative third. The second example also involves multiplication, but I put this one in here because of the units. When you are multiplying or dividing units, you treat them just like exponents, so m times m becomes m squared. The first measurement has 5 sig figs. There's 5 digits before the times 10 to the second. The second measurement has 3 sig figs, 3.05, so you want 3 in your answer. You could write this in scientific notation form, or you could write it as an ordinary number, but regardless, you want to make sure you have 3 sig figs in your answer. So 7.38 times 10 to the 6, and then the units would be meters squared for the 2 meters being multiplied together. The third example involves subtraction as well as division. In order to simplify this, you would need to subtract those 2 values first. So you would get 308. Neither had decimal places, which is why you go out to the ones place. We're dividing it by 200. Now we look at the sig fig rule, and we see that they both have 3 sig figs. The 100, we are told, is an exact value. Exact values are values that are counted or defined. They do not affect your sig figs, so we would want 3 in our answer. Hopefully that one looks a little familiar to you. That's very similar to percent error. So when multiplying it through, you get 154. So again, this video here should help you with, one second, review topic 1, questions 1 through 4. And if you have any more questions, please don't hesitate to get in touch with me.